All right, let's see if this works. Oh my god. Okay, my computer's running hot. That's good. I think. Okay, it's starting to play. Yay. Okay. Wait, hold on. I can't. We're like I'd say welcome, but it's Inception and warnings everywhere. Oh wow. Um, I don't know if sound is like on. Like I should have closed this. Close tab. Close tab. Close tab. Gone. Gone. All right, this works. Great. Okay. Hey everyone. Is there anyone here? Classic. All right, just me. That's okay. What are we doing today? Right. So it's been like again a month or so since wait, hold on. Very messy intro. I should probably tweet out that we are live, but yeah, it's been like a month since we like last were on. I guess the Rust All Hands happened since. Hey, Machi, welcome. Nice of you to join. So the Rust All Hands happened. Been working on some really fun modules in the meantime. Haven't been coding much. I've just been learning how to do some management stuff, learning how to talk to people, talking with people about other things. Machi says, "Wow, somebody actually was able to pronounce my name." I have a friend who has the same name, so that's why I cheated there. I'm not daring to pronounce your last name because I'm pretty sure I would butcher that. So, but yeah, glad you glad you're here. Yeah, I guess the last time I was properly doing some code was while working. Yeah, don't even try. Nope, nope. Where are you from, Machi? I know it's like a Polish name, at least, or also a Polish name. So I don't know. So hey, Fernmeyer, thank you for the subscribe. Poland. Oh, cool. That was easy. What am I up to today? Yeah, that's a really good question. So yeah, what I would like to do today is I would like to do some code. If we'll get to that, I don't know, but it'd be fun. Fernmeyer says they're from Germany. Well, welcome, and yeah, that's cool. I also live in Germany, in Berlin. Whereabouts in Germany? Yeah. So I guess what I've been doing last week, which was kind of fun, is I've been working on my blog, which I'm very happy about. Also Berlin, cool. Is that a bear joke, as in like Berlin? Am I reading that right? That's not my local host, but it's my new blog. It's very big fonts, which I like. So yeah, I still need to update this because I didn't do anything about this. I just made it nice until here, and this is the back button. You can like go all the way back until the top level. This is my new website, I guess, which I'm not too happy about. But it's got a fun little thingy here, which I'm happy about. So that's something I've been working on a little bit last week. Some other stuff I've been working on is I've been, well, a little bit helping out with this thing called Romeo, which is how do you call it? It's I have notes on it. Oh, no, it's wrong. Oh no, it's a reactor is what they call it, which means it's IO bindings, or as they say, asynchronous network primitives in Rust. But we also want to add timers and probably also FS bindings. It's kind of fun. Machi says, I've heard people from Berlin recently discovered credit cards exist. Is that recent? Everything here is still cash though. There's only like a few places where like it's a 50-50 whether or not you can pay with card. If it's a bit more fancy, then probably it's like a corner shop, like a bodega, Späti, is what we call it. And nope, not a chance. Oh yeah. Yeah, I guess it's been like more in the last 3 years. But yeah, the contactless pay is kind of fun. Like the more gentrified shops, they support it, which I tend to go to a lot. I guess. Yeah. Where in Poland are you from, Machi? Hey, it's just the three of us. It's like nice and cozy today. Um. Yeah. So I want to say is I would like to do some code. Poznan, not far away. Oh, nice. Yeah, that's just past the border, right? If you like have Berlin and then you can like keep going to the right and then you cross the Polish border, it's like pretty close there. I think. I remember seeing it on the map one time. I think. Yes. Nice. Great. I've never been. I've only been to like the two big cities, and then there's the other one, the student town, which is also west, I think, southwest, which I haven't been to, but I have a friend who's from there. It seems like a really fun place. Yeah. All right. So I made notes and I was like, I want to talk about 2 things today, 3 things, I guess. I don't even know if I want to do that. I'm a little bit tired. So first one was error handling on my list, which things are changing, and I want to write a blog post about it. And I don't know how to structure it, so I was like, maybe I can workshop it with some people on stream. The second one is about async, but then it seems a bit of a touchy topic, so I don't know how much I should like do there. Like I should probably like give a proper lecture, like prepare a talk and then give a talk on stream, which seems like fun, and then upload that talk to YouTube, which I think would be very useful, but I haven't prepared a talk, so like doing that today might not be very great. Just generally workshopping it could be fun. What do people feel like today? Is it more like anything in particular, or do people have like any questions? I can just answer a bunch of questions. In terms of Rust or JavaScript, if you're feeling adventurous. It's this weird thing where I'm still feeling more comfortable in JS than I feel in Rust, which shouldn't be weird because I've done like years and years and years of JavaScript professionally. Rust is, and changing very fast, and sort of the upper cap feels a bit higher because, at some point you're like, oh, cool, you now know Rust. So here's everything about every operating system that you have access to. And it's like, oh, shit, that's a lot of stuff. So yeah, if you have like any preference, just let me know and I'm happy to like sort of pivot, I guess. Also, there's a cat just walking by. I'm pretty sure cats will show up at some point. I think they know like I'm streaming, so they're like, a little bit shy. Yeah. So error handling. Paper.dropbox. Do paper. Do I do a blog post? I could just like do the blog post. I'll just make the code examples for the blog post, I guess. So localhost, got some errors here. Oh, hey, welcome back, Rihanna. They're asking, do you have any recommendations for any front-end JavaScript frameworks? Preferably train themed. Funny you should ask. Was I looking for real questions? I was kind of looking for real questions. I do like the question though. It's really funny. Are you just happy. Yeah, I guess I haven't like really been working on Chew recently. So people who don't know, I helped build this thing, which is kind of fun. Oh, is that? No, it's still the same cat. It's a front-end framework, which is in JavaScript that's meant to be very small and kind of nice to use, which I like a lot. Quite like the inverted new design on Yoshua.com. Oh, cool. Machi says I'd recommend the no code. Yeah, I didn't like that post so much. It seemed a bit, you know, Kelsey's a very famous person who was like, I'm gonna be funny here. I don't know. I thought I didn't like the tone so much just because of who they are and sort of the influence they have. I was like, when you make a good joke, you kick up. It felt a bit like kicking down, right? What do you call it? Punching up, kicking down, something like that. Yep. And also, thank you. I'm glad you like the design. Yeah. How do people feel about the error stuff? Like, I'm not gonna write the whole post like here on stream because that's kind of boring, but I just want to walk through some of the concepts. I think that would actually make for a fun one, kind of like improv. Jen says trying hard to be funny is not funny. Yeah, also true. I forgot if they were trying that, but you're not wrong. But yeah, not to put a sizzler on Machi's point though. Yeah. Is that an expression? Sizzler? To sizzle out? To be mean? It's like the, I don't know. Yeah. So I had like a few ideas for this post about like error handling for JavaScript people, or like here's a generic overview of error handling and the future of error handling, or just be like future of Rust error handling, or like here's what we're missing. Because I don't like have any proposals. Like Boats, I don't know. I've shown Boats' posts a bunch on stream already. Boats.gitlab.io/blog, I believe. They're really good at doing this thing where it's like, cool, let's start off with like a problem definition, like Waker API 1, what does a Waker do? And then like 2, and then here it's like, here is the proposal to solve all the problems outlined in 1. It's very like from a language design perspective of how to do things. Ooh. I'm drinking fizzy water, so I'm burping a bit. And I feel like the thing for Boats works really well, and they have like this very good tone of voice and like a clear direction in every post. I don't have that, and I don't feel too comfortable like trying to imitate that also. So I'm not sure what to do for my posts. So what I'm wondering is if instead I should just be like overview, like here's an overview, like here's what's going on, here's problems that exist, and here's like the solutions that exist, and that's it. Like bullet point, here you go, ta-da, next one, right? Maybe that's a good flow. Thanks everyone for rubber ducking here. So stack traces, right? Like right now we don't have stack traces in Rust. The error type doesn't have stack traces, I think, or maybe they just added it. What's the thing again? Rust docs somewhere. Rust docs.rustlang.org. Rustlang.org standard. There we go. Stack trace. Stack trace. No stack trace. Trace. No trace. Also no. Unstable. Rust standard stack trace. I believe they were like thinking of adding them at least. SCD format debug. Rust error stack traces from convert. Rust backtrace also no. By the way, Rihanna, what are you working on right now? I've seen like tons of like Chew related things come along. That seems like kind of fun. Standard. Actually, what is everyone working on? I'm kind of curious. I've just like been here in my like Rust hole trying to issue management everywhere every day. Trying to keep the cats happy. Speaking of which, just threw pistachio for Cheshu. Trace. So no backtrace. Oh, tempting for hyperdivision. Oh, cool. With Matthias and Emil. That's cool. Is it for the Heimdall? Heimlich? No, Heimdall. The Heimdall project. Heimlich is, I believe, when someone's choking, you hold them in the Heimlich position or something, right? Yeah, I don't know. Position. Oh, Heimlich maneuver. So you're like, okay, Heimdall. I'm just gonna call it this, maybe for fun, someday. Cool. Like Heimdall, the Scandinavian god person who can see far or something, I believe, right? Oh, that was a cat. All right. But so error stuff. To date, there is no stack trace backtrace. Backtrace. There we go. Rain Dish, welcome. Nice of you to join. So I guess one of the things that Rust needs, Rust standard lib, is the addition of backtraces in the first place, because there's the old caps Rust backtrace and var, but that's like not really. Yeah, you can't, like normal errors don't have them. It's only when you enable them, which isn't ideal. There's a cat here, by the way. I'll throw in a pistachio so she'll have some fun. She loves to chase pistachios. That's really fun. Oh, hey. Hey, Dan. Nice. Welcome back. Rain Dish. Cool. Soriana says, got to spend some time last Friday on fixing stuff because someone reported a high vulnerability at NPM supposedly affected. Oh, wow. Wow. Interesting. That sounds rough. It sucks that it's like, congratulations, error report on a Friday, now just go fix it without like having a heads up. That would have been nice. But I guess we don't have a good security culture, at least in Node.js land yet. Rust land probably also not yet. It's a little bit better because there's like tons of Ruby like Rails people, and they're like running the manager, so they have like a bit more experience there, or at least they seem to be. Sort of. I don't know. At least it's also smaller. Also, yay, Cyberline, welcome back. No, welcome back you. Thank you. Happy to be back. Yeah. So this needs to be a link here. So stack traces. That's one we need. So context. Yeah. So currently let me just jump between topics again. It's like, hey, here's like node stuff and npm stuff. It's like, okay, back to Rust error handling. Rana says it was really annoying because the bug report was basically static eval evaluates code, or fs can read /password lol. What? Ugh, that's terrible. It's like, so for people reading along, it means that, you know, things are working as intended, and that's a bug report. Don't worry about derailing. This is fine. I think it's fine. There was a legitimate vulnerability, but that problem was in a user of static eval. Oh, that's very annoying. And that got, oh, that's super annoying. I'm sorry you had to deal with that. But also, thank you for dealing with that. For people that don't know, like the browserify deps, at least a lot of them are used by like all the other package managers. Also, I'm not sure if static eval is, but I wouldn't be surprised if it pops up somehow somewhere. Yeah. So yeah, they just did a big favor to the whole Node community, which is awesome. And Node means also front end, so that's a big deal. All right, so we have backtracer. Anyway, like going back to error handling. So we need essentially like the picture right now is yeah. Let me start at the start. So Rust has a pretty good error handling story. Like you have panic and you have errors, right? Panic is like, oh, here we like terminate the thread. If it's a main thread, the main thread exits and then your program terminates. In my opinion, panic anywhere should terminate the whole thing, but that's a bigger idea. So panic means termination. If things are bad, quit. And error type is like good error handling. It's like, oh, cool. User submitted a request or something, and the body was wrong, so we tried parsing it. We couldn't parse it, so now return a 500 or something, right? Or like, hey, we tried reading a program file or something. We read it correctly, but the parsing didn't work. Or hey, we didn't have access, so you know that wasn't good. So it's you know you're handling cases that are handleable, and how you react to it is entirely up to you. So that's sort of the division right now. But now we're sort of going into a second stage of error handling. With CSS and whatever specs, you have like multiple stages where you incrementally deal with more cases. So the base level of Rust error handling is pretty good. We have good syntax support, all this other stuff. And now that we're going a bit further in, some other things are starting to pop up. Most importantly, like about a year ago, slightly over a year ago, Boats created a correct failure to be like, hey, I think these are the things we need for better error handling. And they had like some interesting things in here. Most importantly, they essentially took some existing userland things and they were like, here's my take on how to make things better. And it's pretty interesting. So very importantly, like foundationally, Rust's errors, they do not have a backtrace. That seems to be a big thing that we're missing. We probably kind of need backtraces. They seem fairly important. Right, so here's a backtrace. Here's the source of the backtrace. Right, so there's internal backtrace internally, and then create some instances of stuff. All right, here's the internal backtrace, I guess, without backtrace. I don't know what all this means, but you know, it just does a bunch of stuff to, as you unwind the stack, keeps information in there, and then all the way at the end of it, you have your trace as it has unwound. So that's useful, right? This needs to move to standard, like ASAP, probably. Or at least it seems to make a lot of sense. How to get there, that's a second question, but you know, that's foundational and that's kind of missing. Wait, let me, can I skip this? Because I'm just not typing. No, I can't skip it. All right. So there's I think that might be like the only foundational one that's missing, but then there's some other stuff, which is along the lines of how do we handle errors? More importantly, it's like every error or all code is like words. So you can think of code as like instructions for machines, but more importantly, you can think of it as like instructions for humans. It's like explanation of what is going on. Programmer reads the code and you figure out what's going on, or the program acts and then something goes wrong or something is correct, and then you read the output out. At the end of the day, we all need to like deal with the input and output of these things, and be able to read the code, and that's how we work with it. And like backtraces are kind of awful for that. Like if you look at a backtrace, like in Node.js, like Rust backtraces are pretty similar. Node throw new error, hoops, sure, error hoops, function foo, right, throw new error hoops who. All right, we do need to close our parens correctly, like that, foo, there, right? Now we do that, and then we can like closure it all the way through, and then right, so error who at foo REPL 124. So we see like, oh, it was called like from the function foo, bubbled up one layer, and there it is. Now imagine if we somehow had like functions upon functions of calling things that goes through a framework, right? And then it pops out on the other end, and maybe there's stuff that goes async even, right? So it gets like put on like a queue for a while until a FS event wakes it up. And then you're like looking at this error and like context gets lost. Like a stack trace is generally not unwind over async points because it's an actual like pausing point. So a thing we could do there, which I think we also should do, is past like yield points, keep the stack so it unwinds past yield points, aka asynchronous stack traces. That's very important because if you try and recreate this, that's actually how it unwound, and the fact that like got intermediate steps there, we should capture that. Chrome is moving towards this. There's a thread somewhere that I should pick up. There's like a post on how they're going to do it, which is very useful. But that's still like geared towards computers essentially. Like a stack trace is just a list of this is the where everything was touched, right? Like more towards humans is a causes list. It's a list of why did things go wrong. So you can think of it more not quite as a stack, or kind of like stack trace. It's like a stack, but like with things that went wrong for humans. So say we got a file system abstraction or something, right? Or we have a networking protocol or whatever, like that protocol that I've been working on. Say we try and like do something and it gives us back an error, right? Then we could look at the stack and it would like go through like 4 layers of dependencies, and it's like, wow, what's going on there? Like inside of a trait that is implemented by a different thing that is doing particular calls, and looking at the stack trace will just give you like, oh, dependency 4 layers deep, line 23 of file librs had an error. That's the origin of the error, right? Had a FS error. It's like, okay, cool. What FS error? What were we trying to do, right? And then you go into like archaeology road and you spend a bunch of time like going through all these depths and trying to read the code and figure it out, and it's not great. So what we want in that case is actually a list of reasons why it went wrong. Like, for example, we had a permission error. We weren't allowed to like read this, right? Why weren't we allowed to read this? Or sort of like, or actually the other way around, like a particular write operation failed. Why did the write operation fail? Well, because writing inside of this trait thing failed. Okay, why writing in a trait thing failed? Because the block offset was wrong or something, right? And then we're like, oh shit, like the block offset was wrong? That's a problem. And can like try and like convey this information like through a list of reasons, or as they call it in failure causes. So that's what this thing is for. An iterator over the causes of fail. So you can iterate over all causes. And there's this one package called exit failure, which gives you exactly that. So it looks at failure and the causes struct. and then you do it in your main function, like exit failure right here, right? And then if this fails, so it's like here's the root error, and then we add dot context to it. There's some context, and we see, okay, cool. The root error. This was the root failure, and then here's the context, right? It can be like this thing failed and this thing failed, and it's kind of fun. So that's kind of useful. Hope that makes sense. Oh yeah, there's people following along. Welcome everyone. Also, don't be shy to say hi, or like interrupt me at any point if you have like any questions. I'm just kind of ranting on, rambling, not quite ranting. Hey. So failure context. I'm just gonna add the links for stuff that I need to like. So there's exit failure. Cogno Marco, you got discovered. Yes, I sometimes just check it to see if like who's tuning in. Are people like around? Welcome and thanks for passing by. I appreciate it. Yeah. What was I saying? I was saying something. Oh yeah, so there's exit failure here, and then we need the context one. The causes, and there's context. I think this is not great name. Where is it? Context is intended to be causes dot cause context. Where is it got returned from? I'm trying to return types. Fair L fail. All right. So here's the one, the context one. Exit failure and context, and causes failure error causes iter chain. Cogno Marco is asking, so what do you do here? First time I got here. That's a great question. So I guess today has been the first day in a while that I'm like back streaming. So just going through like some Rust error handling stuff. Like usually what I like to do is I like to just work on problems and talk with people about what's going on. Maybe I can answer some questions or something. But yeah, today it's a bit more. This is a blog post I really want to write. So I'm just going through the research, going through all the links I need to pull up and explain stuff as I go along. Helps me. Kind of like a lecture, I guess, but a bit more laid back. It's not quite as formal. Like if I was actually prepared, then I could give a lecture or a talk, but I'm not. So it's kind of preparation for that, for a blog post. Saddle method causes. Oh damn it. Does that answer the question, Marco? Marco's asking, what do you use Rust for? So last year I started building a network protocol in it, port of the DAT protocol, which is kind of like BitTorrent, but has some cool other things. And these days I work on the async stuff, trying to help the ecosystem get there. So yeah, when you're saying like, hey, I'm really interested in language but feel the ecosystem is not there yet, then you know it's kind of my job to help us all get there, because I agree, like there's some parts that are really well developed. If you stick to synchronous code, it's really good, I think. But if you want asynchronous stuff, which you know it's always a question, like do you really need it? Then things are not quite as mature, right? It's a bit fragmented still. So we want to go cross that bridge and get there. What kind of stuff do you work on? Also, Cyberlion's asking, when should you panic? Any tips? So a panic is generally done when, to be fancy, it's like when a invariant is violated. And then what does that mean? It's like, well, in generally speaking, what you want to do is you want to catch as much stuff as possible with the type system. So say we expect a particular number to come in, or if you want to write a GUI. Oh yeah, that's also true for ecosystems not mature yet, but GUIs are all async, so you know. Yeah. So generally, you want stuff to be caught at compile time. So you know, if you expect a number's not passed in, like any number type, whatever, then hey, that's not a number type. Error done. Particular other type, you know, it's like, hey, that's not being done. Then some other fancier things is with const, just the const keyword, you can do compile time evaluation, you can do computations and stuff, and then you get other results out, and that also happens at compile time. Now, in panic is a way of enforcing runtime constraints, because sometimes you can't figure out if that something you can't figure out something at compile time. So say we're trying to index into a vector, right? So we have a list of numbers or something, or a list of memory pages or whatever, and we're trying to index into a memory page that doesn't exist yet, right? We need to manually create a bit of logic so we index into a right page, but the code will panic if you try and reach a page that wasn't created yet, simply because the you know, it's like, cool, you're trying to access uninitialized memory. Other languages might core dump on you. Rust is like, no, we're going to panic. And it'll tell you like, hey, you try to index 7, we only allocate 4 pages. That's wrong. Fix your code. So it's the kind of stuff where you wish you could enforce it at compile time, but you can't. So you're enforcing it at runtime instead, right? Like second best. Ideally, you do it as fast as possible, like at boot, but sometimes it's like just runtime stuff, like indexing into a vector, right? Better get your logic right, so then you write tests to make sure that that's correctly done. Or it's like, give us a what do you call them? Not integers, but the other ones. Give us a floating point number between 0 and 1, and then you add an assertion or a debug assert that says number must be above 0 and under 1, right? Like either 0 equal or like under, like not higher than 1. And then if that's violated, then someone passed in a wrong number. And then you just document that behavior, because the what do you call it? The type system, that it can't enforce it quite yet, right? So in Rust, they're trying to make the type system more advanced as they go along, to be able to support more and more things, to be able to be more flexible. There's even a whole field of stuff. Damn it. I have a book here about the topic. I forgot. Anyway, there's like very fancy type systems out there. There's a particular flavor of type system that Rust has, so it's like not going to be able to do all particular things. Dependent types, it will never likely never have dependent types, and that's okay. Dependent types essentially allow you to like write very fancy constraints and then proof that your implementation does that. They're useful, but they're also very, very verbose, or they're not practical yet. And Rust tries to be like stable sooner rather than later, so I can't really wait for research to catch up, because that research is like not even done yet. So you know, we're waiting for it. The next Rust might have that, but yeah. It's a bit of a long reply to your question, I guess. But does that make sense, Cyberline? When you should use panics? I hope. It's less practical. I guess it's more like theoretical, a bit. So Marco says, I'm in a vast world of game development. I'd like to try Rust for that, but using it on a small project is different than using it on a big one. So I'm scared that because the language is so young, I'm going to have problems difficult to fix. Yeah, that makes complete sense. That's fair, right? That's with everything. if it's younger rather than older, then there's going to be less documentation. There's going to be fewer Stack Overflow questions. There's going to be less of an ecosystem. Sometimes there'll be like, you'll need to like build out a foundational thing yourself. That might exist like in Unity land or something, right? They have it, period, and then you just want it. It doesn't exist. Oftentimes what that means is sort of like a trade-off. It's like, right, maybe it is not the right tool if you like have a very tight deadline. But if you're like not afraid, or you do have the opportunity to invest a bit more time, then you're actually able to create that foundation that you can become a household name. Whether or not that investment makes sense, that's up to you. That very much depends on where you're at. But you know, recreationally, it might be fun. Maybe sort of as an experimentation phase, that might be very interesting. I know there's companies that, you know, they're not going all in on Rust, but they're interested in it because it does sort of foundationally, it solves particular problems that, for example, C++ has, or for example, Golang has. So they're starting to experiment. They're like trying to get a feel for it. They're trying to get some people to understand it better. And then slowly, if those experiments turn out okay, they slowly start to introduce features in it, like a small service built in Rust, or like a small component built in Rust, right? And then they iteratively go in there. And then there's like other companies that are just like, no, we've tried this and we're just going all in. So, you know, that's a bit up to you, I guess. So I guess I'm just doing QA now. Okay. That's actually a great use of this time, I think. Probably going to do this until like 5:30-ish. Maybe 6 even. Let's see how it goes. Cyberland says, yes, I get it. So basically try to catch all the errors you can catch at compile time and use panic for runtime errors or errors you can't catch at runtime. Yeah, essentially. So there's a few flavors of panic, right? You can say we want to do a function or something, right? And we say return results and whatever, right? And then we're like, oh, we can essentially create a typed hole there. It's like do thing, right? We're like, oh, we don't know what that's going to look like. If you try and call it, it will panic, right? But it returns that signature, so it's just unimplemented for now, right? Like this will panic. Another interesting one to know is phonefoob is debug assert. Like here, expensive assertion, right? Like if you're like doing a very expensive check at but only for your debug builds that you want to like remove in production, use debug assert, right? That's pretty useful. For panic, Rena says, for panic, I only use it if the error is caused by misuse of your API. Yeah, that seems about right. But also there's another one, unreachable, where unimplemented means this is just work in progress. Unreachable means, say we have already our constraints ensured and that path should never be able to be taken, right? If you like do a manual loop and then you do a break, then after that you still need to return something. But if you say unreachable, then we just say like, hey, we checked our code, this should never be hit, and if it hits, it's a panic, right? So there's different flavors of upholding those constraints, essentially. Yeah. So Rihanna says, if you got there, it's a bug in my API, essentially. If the error is caused by some environmental fun time, like follow permissions or dead internet, result is always more appropriate. Yep, that's exactly the thing. And you can still bubble up the result all the way to the top, and your main function just, you know, it still exits. But the way it's displayed then becomes different. It can just be like, oh, here's like a list of causes. And the end result is internet died. Sorry, couldn't make any requests. And you're like, oh, okay, cool. Timed out. Like, that's fine. Or could never even like access it. That's also fine, right? but that's very different than getting like a stack trace of like, whoa, you really messed up here. Marco had a question. Even at a smaller scaler, OpenGL works perfectly for C++. I think the Rust bindings exist, but is it perfect? Do I have the guarantee that whatever I try to do, it's going to work? Well, obviously, no. I don't have to get into the binding and fix it myself, basically. I don't think that the word obviously no is well placed there. There's a really good graphics community though, like GFX HAL. I've heard like really good things about this. How good it is, I don't know. I haven't tried it, but I've heard really good things about it. And I've also heard like plenty of friends swear about like OpenGL itself. So you know, is this the right one? I don't know, but you know, I feel yeah. Like, yeah. I guess how you say that. The thing with C++ is if you write code and that works, right? Like you write 2 layers of code or whatever, then that works and compiles and it's fine. And sometimes you modify either one of the layers and then perfect fine code that you wrote. Like something like a detail changes underneath it and suddenly your whole thing can like break in random ways. An example of that was someone I know wrote a post about this, Sean Griffin, about how he wrote some code and it was fine. And then they had the idea of, yeah, let's move from a normal mutex to a reentrant mutex. And a reentrant mutex is you can drop a lock and then reacquire a lock and you'll have the same lock, and that like has particular behavior. It's slightly different, slightly more performant. It's what they needed for particular stuff, right? And by changing from a normal mutex to a reentrant mutex, things broke wildly, right? But like in Rust, it was like, oh, cool. This should not happen. There was like a send trait that wasn't implemented, so it wouldn't compile. And I was like, oh shit, we should never have tried this because it's a terrible idea here. But in C++, you would not have been warned. And in isolation, like catching that bug is not possible, right? If you just look at the code, it's perfectly legal code and everything around it might still work, and even tests might like still pass. But if you look in the wider context of every single place where it is used and how all those places interact, then that use of it suddenly becomes a terrible idea. So the thing with C++, I think, is you have to manually check all your invariants everywhere for every single change. If it like crosses like between it, right? Which just seems like a lot of work, and you need to be extremely careful. If you're sleepy or tired or just forget about it or new to code base or just a big code base, then those things will break. And yeah, I think that is a thing for Rust that's kind of nice about it, that the compiler really does have your back. Marco's asking, do we have any info for Rust 2019, 2021? Sort of. I guess not really. They're drafting the post for it now. I know that to make any form of like roadmap for 2019 useful, it needs to be launched at the start of 2019. So before the end of next month is what people have agreed to like do. So that's likely what's going to happen. I was in a meeting for the roadmap 2 weeks ago. I don't know if you read like a lot of the posts, and you're sort of like start to figure out like, oh, there's recurring themes here. So posts will likely, like the roadmap will likely include those because that's how people are feeling. So yeah, that's, there will be a post soonish is the answer there. Is that a non-answer? I don't know. But it seemed a lot of people like agreed a lot. Big thing was that getting the 2018 release out was very hard on some people. There was a big push that was very straining. So some people, albeit they didn't quite burn out, or maybe they did even. They just, yeah, it was just very hard on them. So yeah, the people want to figure out also ways in which to make all these releases also future facing, like making this year like less taxing on contributors, which I think is a really good thing. This was just like anecdotally, I don't know if this will like show up on the roadmap, but it was definitely a thing that everyone was like, oh yeah, we need thinking about the people is very good to like talk about and figure out ways in which we can all improve. So I'm very happy about that. Not that people need my approval, but I'm just I went out like feeling very optimistic, which is great. Not that I wasn't, but you know, blah blah blah. Anyway, yeah, this is great for graphic stuff. It's useful. GFXRS. It like compiles down to Vulkan, DirectX, Metal, OpenGL. And it tries to like be the unifying abstraction layer, and then you can like compile this stuff that works with this, and it just works everywhere. Which means you can write the same code for browsers, Mac OS, Windows, right? If it supports all the fancy features, I don't know. I haven't tried it. I also don't know too much about it. But given that it's targeting Vulkan, my guess is most of the fancy features you can like build yourself if needed, and there's gotta be a small percentage that probably won't work. But that's okay if that means you can ship your game or graphics project to like all the platforms. I think that's very promising. I'm not sure if this is a project that was used in Firefox now, but they're definitely, oh, the web GPU. It might be. Because, yeah, this thing needs to ship at some point in Firefox, or at least a version of this. So, yeah, I know. Yeah, all right. Guess we've done a good QA time here. All right. All right, let's take a look here. So as context, we need the async stack traces. I think I have like a Google Doc somewhere. Google Doc, yeah, I can pull it up later. That's essentially, do I have it here somewhere? Presentation, V8, TSC. Nope. All right. Goodbye. Yeah. Anyway, the V8 people, they had an idea on how to do async stack traces. So I'll need to pull up that. Oh, there's also a cool thing. I'm really curious what Rust looks like here. Where you can do, say we have a future. Wait, can I code this out without making opinions about async await? All right, so say we had a wait foo, right? Like context bar or something. Fun async fun beep returns a result of nothing or error, whatever. Just making up a thing here. All right, let's see if this renders at all. There. Oh, wow. Wow, that's pretty good. I had no idea this would actually be that good. I just need to add like some padding or something. That's like acceptable. Like this reads not bad. Which I'm very, very glad about. Right, so in this example, what we're seeing here, I just blurbed all over it. Like, don't fight me on the syntax, please. So what happens here is where foo would return a future, right? Like foo is a function that returns a future, but we're like, hey, we also know that that future is going to resolve into a result. So for, I guess internally, let me just do the definition. Like, I'm so happy with the syntax highlighting. It's like surprisingly good. I'm just really curious what this looks like. Will this work? Will this work? Oh, damn it. Wow, that's also good. It's amazing. All right, but we don't rest. So impl t, what is it? Impl t t future where item equals result of TE or something. Fun context. Or implement for try future. Just dot context where it internally resolves to like an error type. And then here we would like call e.context or whatever. I'm not sure how to implement it, but that's the base idea, where we take this like generic implementation and then we like keep it sort of generic, but we know a future where item equals result. We then expose a context method on it, which would be possible in the standard lib, which I'm pretty happy about. That's like even a possibility. There we go. Right, because if you take this as a whole, in order for the bindings to work properly, you would sort of need to consider this like this, right? Await foo.context bar. Now we're able to like strip all those things away, and this becomes one thing. Request URL or something, string. Yeah, there we go. Dot context. Could not make request. Something like that. Is this fantastic? No, it's not. Anyway, so that's one fun thing that's possible. Async stack traces is also possible. Does this make sense to people? What I've like just described here, albeit a little bit clumsily. It's more or less the fact. Right, to put it in perspective, it's the fact that instead of like needing to do a let binding here, that you would be forced to always like you can't resolve that one, and then you would need to do let whatever we just had there equals res dot context or something, and then question mark at the end. Like, it can become a one-liner, it can become like a single thing, right? So this is not forced, because if we implement like for a future of results, if we implement a context method on there, and context would be part of standard lib, then we could tie it all together into like a single thing, which was a really cool insight, I think. Hope that makes sense. Anyway, Probably like another cool thing is people are talking about like perhaps doing a new syntax for error handling, which I personally really like. I used to think it was terrible, but then I started thinking about it. That's pretty good. So right now what you see here, right, is you have a function that returns results of type something and error. And then here at the end of it, we're returning an OKF unit, especially when you take a mutable argument. That like OKF unit, you just see it everywhere. It becomes kind of noisy, and it's like, oh, what's going on there? And then like the nesting of all the things becomes also a bit like, And we're like adding syntax for async functions, which is pretty useful because we expect it to be like extremely common, right? Like with UI development or like web development or anything in between, like async is a very good way to talk about these things. Like you parallelize it. And same with like error handling, like fallible operations, they're super common, more so than like most other things. So having specialized syntax for that is kind of interesting. So do something, right? We would take an x, a mute x of nmute thing, right? And we return like we would return this, and then what is the thing about box impl error plus static or something, right? That was pretty lousy. Yeah, we can remove the static here. Impl standard error, standard error, like that. And then this is generally how we do a thing. You know, you say let plus equals 1, let add 1 or something, right? And then we return nothing. And we still like need to do this, right? So instead of like doing this, let's copy this whole block here. Something people are talking about, which I really like, is being able to do do something. Actually, let's copy just this, right? And instead, we say throw error, right? Like have a dedicated box error type also, but throw error and then let add 1. And what this does, it removes a lot of noise. It just says when this thing's called, we can throw error. And throw error would be just a way of saying like, hey, create a new error. Oh, sorry. In this case, this is just for a signature. It just says, hey, it propagates upward. When we say we have the try operator, and we have the, I believe, also catch blocks. Try blocks? No, we have try blocks. We don't have catch. You know, we could, yeah. Wait, hold on. Phrasing. Essentially what this does is it just makes the error handling so much more obvious. Like if you have a long chain of stuff that just says like, hey, here's like the important stuff. Like it can throw an error. What kind of error? Oh, very specific error, like an IO error. Or hey, not specific at all, like it's a generic error. Right? And then this sort of like explains it a bit better. I wonder if this like shows up nicely. Simple box error. All right. So my I need to add overflow scroll. Yeah. Throw failure. Yeah, I wonder about this. We should have something better than box impl error. Yeah, let's make that also one. Stack traces, context, box error, failure struct, failure error. right? And sort of like combining all these things is what we get. Wait, how long have we been streaming? We've been streaming for 1 hour 5 minutes. I might run to a loo in a sec. But yeah, sort of if we consider, wait, let me change this thing here. So here's what we talked about. Let's change this. I should do my research and figure out what people are proposing for this. Failure. Use standard prelude failure. Right, like the prelude's always imported, so you can like re-import it, no problem, I believe. And there's like a result of type something and failure. And then if we do use standard prelude failure, we could remove this and say failure here. Throw failure. Copy this, paste it there. Right, and then we look here, and then we can see that essentially, like the error handling for all of this stuff would go from, well, we don't need this. All right, we should have the prior version and copy that. All right, let's copy this. Woo. Right, we would go from like this stuff where you need to include standard error and like box impl error plus send plus sync. Actually, send plus sync plus static. I believe that is the correct way to define errors. Right, like if you want to have error handling completely correct, then those are trait bounds you need. Which is pretty mad. We could go from like result failure and like go all the way down to just like have throw failure or something like that. There should be a different word for it. If you couple that, like that syntax, I think would be very nice to use. Creating a new error could be done using throw. If you just had like a particular error type or something, or inherit from the error trait somehow. I'm a bit fuzzy on the details there. I really need to like polish this whole post to like make sure that all the details are correct. But yeah, like I think the end result will be rather nice. Like here, mute add, and then wait, mute add, and then here question mark. That's the thing. Oh, x.add. Damn it. We need to say x. Right, like here x.add question mark something, and then we could have this yeah, we can even like remove these here to make it a bit more clear. Right, we would go from all of this, which is the correct way of doing stuff, to just like this. And yeah, I'm pretty excited about that. Add async stack traces, add human readable context objects, add a really good I tweeted about something which I think is kind of fun. I'm really just talking to myself right now, I feel. Are people still around? Yay, you're all still around. Happy. Yeah, I made this post here. Essentially, like at a top level, get a exit, like get the exit codes right. I guess that should be like another one. So you should be able to like get all the standard exit codes, have standard lib, implement all the correct exit codes if they get bubbled all the way up. And if you hit that using the exit failure crate, or in this case the exit crate, be able to log a list of causes using the log crate. I think that would be fantastic. That would like just round out Rust's error handling story. Like just make it correct at every single step, and the most convenient thing of all languages at every single step. We could then hook it into the man crate, so you can document every single type of failure, right? It would hook into your logging infrastructure. So if you're like logging through Google's logger, then yeah, that works. Or you're logging through a system logger, that also works, or systemd or whatever, right? All those would just nicely integrate, which I think are very nice. What do we say? Exit failure context. Laying. There you go. I guess we're mentioning exit failure here. Right, but yeah. It's sort of like how do we slice this? All right, I am going to run to the bathroom, and that's what I'm gonna do. All right, 2 minutes, be right back. Hey. Hey. All right. Are people curious about anything in particular? Otherwise, I would talk about async stuff, but I probably shouldn't yet. We've like been working on some really interesting things. I haven't worked on the NGH2 crate since the last stream, which has been like about a month, which I'm a little bit sad about. Yeah. Yeah, I don't know. Maybe this is like a nice ending. Maybe I just shouldn't pivot into something else. We've done a little bit of Q&A today. We've talked about error handling. I actually pulled up all the links that I needed. Came up with like some fun extra topics. I really want to write that blog post, by the way, to just talk to people about like the current and future status of error handling in Rust. And yeah, just kind of go from there. Yeah, it's been really good. It was very useful for me also. So I think I should call it a day. And thank you all for coming out. It's very appreciated. I'm going to try to do these more frequently. I think I end every stream with being like, I'm going to do these more frequently, but like actually, at the start of the week, just look at my calendar, and be like, oh, that looks like a great spot, and then just reserve it, which is what I did today. Just happened to be that this afternoon I didn't have like any fixed work, anything that I needed to attend, so I just did this. So yeah. Thanks everyone, and I'll see you in the future. Hopefully, I'll announce it on Twitter when I go live next. So see you around, and thank you, and bye.